More on the Linux command line. In this nugget, we're going to learn Linux commands that relate to environment variables. We'll talk about redirection operators and the pipe operator. And finally, we'll talk about grep, which is a very powerful command that's used for searching text documents. So let's get to work. Well, the first thing I want to do in this nugget is talk about the shell environment. Basically, when you log into a computer, you have a bunch of environment variables set for you. These environment variables control some basic functionality of your interaction with the shell. Okay, the best way to explain environment variables is to show you what they are. Okay, and the way that we can see what all of our current environment variables are set to is with the env command. Now what I'm going to do here is I'm going to hit enter, but a whole bunch of stuff's just going to scroll by on the screen really fast, and we're only going to see the very last page of environment variables. That's okay for right now. I'll show you later how to see every single environment variable that is set, but for right now I just want to hit end and give you an idea of what these environment variables are. Okay, so we're only seeing sort of the last page of output of the env command. All right, the thing over here on the left, this thing that's in all capitals, is the actual name of the environment variable. Okay, environment variables are all capital letters. So this one is a very important environment variable. It's called the path. This is where the computer looks for programs that you type. Okay, so like when I type pwd, for instance, or cd, or something like that, what the computer does is it first looks for that command, say pwd, we'll use that as our example. It will look for the pwd command in user local bin. If it doesn't find it in user local bin, then it will look in user bin. Okay, if it doesn't find it in user bin, then it will look in bin. If it doesn't find it there, then it's going to look in x11r6 bin, or user x11r6 bin. And if it doesn't find it there, then it's going to look in home peri bin. And if it doesn't find it there, then it's going to return a message to you that says, sorry, there is no command called pwd. Okay, even though that command might exist somewhere on the system, it doesn't exist in any of the directories specified in your path, so the computer stops looking. All right, so for most normal user commands, user local bin, user bin, and bin are sufficient. Okay, if I write programs myself that are executable programs that I can type at the command line, I would put those in home peri bin because they're like my personal programs that other people aren't necessarily going to use. Okay, so the path environment, that's a very important variable that is set for you naturally to this. If there are some commands that you need to use because, say, you're a system administrator or something like that, then you would need to add a couple of other paths or a couple of other directories to your environment, to your path environment variable. Okay, and we'll show you how to do that in a few minutes. All right, and as you go down here, you can see all the other environment variables. I'm not going to talk about all of these. You can see here's the pwd one. This one is actually your current working directory. All right, and when I change my directory, if I went down into the .mozilla subdirectory, for instance, then this environment variable would change, okay, as soon as I do that. You can see down here there is a home environment variable. Now this environment variable doesn't change, okay? This one stays the same through my whole session, and it explains exactly where my home directory is on the system /home/peri. Okay, so this is the kind of stuff that is set with environment variables. Now let's look at how to actually make an environment variable change. All right, well, now what I want to do is show you how you can go and change a particular environment variable, okay? And the way that we do that is with the export command. Now, what we're going to do with this particular example is I'm going to change my path. I'm going to add a directory or two onto my path so that the computer will look in a couple extra places before it returns the message saying it can't find that particular command that I typed. Okay, so what we're going to do here is we're going to type the name of the environment variable that we want to change. So that's the path variable. Then I set an equal sign, and now I type out what I want the path variable to be equal to. Okay, so this is an important point. Now, if I just type in here, say /user/sbin as a new directory that I want the computer to look in for a particular command, then what's going to happen here actually is everything that path was equal to before is going to be wiped out, and all my path is going to be equal to will be what I type here, /user/sbin, for instance. For this particular example, I want to preserve all of the things that path was equal to before. So what I'm going to do is I'm going to type $capital PATH. Okay, the $capital PATH says make path equal to everything that it was equal to before, and then followed by this colon, I'm going to write all the new stuff I want it to be equal to as well. All right, so the stuff that I want to add on to the current setting of the path variable. So the stuff that I want to add on, let's say I want to add on user sbin. I'm going to put another colon, and I want to add on /sbin. Okay, now these two directories are really for system administration tools. There's a lot of system administration commands like add user and things like that that are in these directories. Okay, so that's why I'm adding them on, because when I do system administration stuff, I want those two things to be in my path. Now, I could really add this to the path of the root user, since I'm going to be doing those system administration tasks as the root user. I'm just doing this for demonstration purposes so we can see how to change the path variable. Okay, so let me hit enter here. And now what I'm going to do is I'm going to type env to display our current environment. I'm going to hit enter, and again, a bunch of stuff's going to scroll by on the screen. I just want to look at the path variable again. Okay, so here you can see what the path variable is set to. And it was set to everything it was set to before up through home peri bin, and then there's two more things tacked on the end here, /user/sbin and also /sbin. Okay, so you can see now that we've actually changed our path environment variable. And let me just use the up arrow key here to remind you how we did it. And remember, if you want to preserve the variable, and just add on to it, then remember to use the $path at the front of this. And this is probably the most common environment variable that you will change. And so that's why I showed you how to do this particular one. Now let's take a little look at how we can see the entire output of the env command. Okay, remember that when we typed env, more than one page of stuff came up. Okay, and we only saw the last page of that because there was too much text output from that command. And this happens all the time in Linux. You execute some command or you run some program, and the output of that program is, too much text to fit on one screen. All right, so here's one way that we can do this. And this is not necessarily the most graceful way to do it, but it's going to lead to that most graceful way. And this is useful in its own right for other reasons. Okay, what we're going to do here is we're going to use the redirection operator, or the greater than sign. And what I'm doing here is I'm saying execute the env command, but redirect the output of that command to this file name. Okay, let me just call the file name env output. Okay, now I'm going to hit enter here, and what's going to happen is all the text that would normally show up on the screen when I hit env is instead going to be redirected to this file, and nothing is going to show up on the screen. All right, so let me hit enter here, and now let me do an ls, and you can see the env output file that I just created. And now we can look at that file page by page with the commands that we've already learned, like more or less or something like that. Okay, so let me just say here, more env output. All right, now I'm going to hit enter, and now we're going to see the first page of the env output file, which is actually the output of the env command. Okay, you can see some other shell variables in here, some other environment variables like host name, which is the name of the machine that I'm logged onto, the shell that I'm using, which is the bash shell. Okay, I can hit spacebar here and page down, and now you can see the second page of the env output. And then I'm going to hit spacebar once more and see the very bottom here. Okay, so it was, a couple pages of output from that env command, and this is one way that we can look at it, by redirecting that to a file and then looking at the file page by page. All right, so that redirection operator that we just learned is useful if you want to save the output of some program or some command, if you want to save it for, some period of time. Say you're running some program that's like a log file analyzer, and you want to save the results of that analyzer into a file, and you want to compare them day by day by day. Okay, so that would be a good use of the redirect operator. The way we just used the redirection operator, though, was just so that we could see, the multiple page output of the env command, so that we could see it page by page. Right? Now that's kind of clunky the way that we did it, because we created this text file and then we said more on that text file, and we have this text file sitting around now that I have to go ahead and delete, or it's going to eat up disk space. There's a more elegant way to display the output of the env command page by page, and let me show you how to do that now. So one way that I can do that is I use the pipe operator, which is a vertical bar. And what I'm doing here is this pipe operator is connecting the output of the env command to the input of the more command. Now we know both of these commands already, right? The env command prints out all the environment variables to the screen, and the more command takes the text file and displays it page by page. Now normally we've used the more command and we've said more, and we followed that by the name of a text file. But you can also use the more command like this, where I'm piping the output of env into the more command. Let me hit enter here and you'll see exactly what happens. Now what we're doing is we're seeing the first page of the env command, the first page of output. If I hit spacebar, we'll see the next page of output. If I hit spacebar again, we'll see the very end of the file. Okay, so that's a more elegant way to see every page of output of a particular command if you don't want to save it. Okay, if you want to save it, use that redirect operator. If you just want to see it on the screen but you don't want stuff to scroll by and that you might miss, then use, like, you take the command and pipe it into the more command or the less command or something like that. All right, now let's talk a little bit more about pipes and also a little bit about what are called wildcards. So what I want to do here is first, to start this discussion, is just do an ls-a on my home directory. Now remember, this lists all the files in my home directory. So it lists the regular files like env output and junk, but it also lists the dot files, or these configuration files that are sort of hidden when you do a regular ls command. And remember, the colored ones here are the directories full of configuration files. Okay. So one thing that I can do with the ls command, instead of just doing an ls or an ls-a on my current directory, I can actually do an ls for some other directory. So just take this example, for instance, like ls.gconf. Gconf is a directory full of configuration files, and if I do an ls.gconf and hit enter, then what happens is the listing for that directory shows up. So these are all the subdirectories and files in the .gconf directory. Same goes if I do ls.gconfd. Okay, then I can see the stuff that's inside of the .gconfd directory. Okay. So just say, for instance, actually, let me show you one more thing first. Let me also take and do an ls on a regular file, like ls.gtkrc. Okay, now if I do that ls, all that shows up is the actual name of the file. Now this might seem a little bit silly, but this is already a file name, right? So there are other options for ls where this would make more sense, where I could do a listing of just a file name instead of a directory. One of those, I guess I'll just show it to you right now, like ls-l. What this is this is a long listing. So what this will do, if I do this ls-l on a regular file and not a directory, then what happens there is it tells me who owns the file, what group owns the file, when it was created, also some permissions on the file. This says that the owner can read and write the file, the group can read the file, and then everyone else on the system can also read the file. Okay, so we'll talk more about these permissions later. For right now, I just wanted to show you what happens when you do a listing on a regular file instead of a directory. Okay, so that's a little bit of a setup now. All right, so we've done a listing of some directory like the .gconf or .gconfd directory. We did a listing of this .gtkrc file, and it just shows up with the file name. Okay, let me clear the screen, do an ls-a again, and now what I want to do is show you a little bit about what wildcards are. All right, so say I want to list out the contents of each of these directories that start with .g for some reason. All right, so the one way that I can do that is just go one by one and say ls.gconf, ls.gconfd, ls.gnome, and so on. A more efficient way to do that would be to say ls.g*. The star here is a wildcard, and that star matches any character at all. It matches letters, numbers, dots, hyphens, underscores, everything, okay, is matched by that star. So this will list out files and directories that start with .g. All right, so now if I do this and I hit enter, you're going to see a bunch of stuff scroll by on the screen, and basically what's happening is for every directory like .gconf, there's the contents of that directory. There's the contents of the .gconfd directory. There's the contents of the gnome directory. But a bunch of stuff scrolled up the screen on us. Okay, so again, let me clear the screen, and now let's go back using the up arrow key to go back to the command that we just executed, which is ls.g star. And here what I'm going to do is I'm going to use the pipe operator again, and I'm going to use the more operator. And what I'm saying is take the output of this ls command and pipe it into the more command so that I see the output of this ls command page by page. All right, so let me hit enter, and now I'm seeing the output of the ls command. So these were the regular files, .gtkrc, gtkrc 1.2, and so on, okay? So the regular files just show up. But when a directory shows up in this listing, all right, then the directory shows up followed by a colon, and then all of the stuff in that directory shows up. Then there's a blank line. Now there's another directory followed by a colon, and then the stuff that's in that directory. Okay, so there is another example of using the pipe operator, and here we're using the pipe operator on the ls command, and in that ls command we use what's called a wildcard to save us some typing, and it allows us to match all of these various files that start with .g, and like I said, it's just a more efficient way to list out the contents of all of those various directories and files. Now let's talk about a very powerful command in Linux called grep. Grep stands for get regular expression. All right, so forget about what a regular expression is for right now. What we use grep for is to search for strings or characters or words inside of a text document. All right, so what we can do here is we can grep for a particular string like Perry in the etc password file, for instance. And now what's going to happen as a result of this command is every line that has the word Perry on it in the etc password file, that whole line will be printed out to the screen. Okay, so let me hit enter here and let's see what happens. All right, so this is the file, this is the line from the file etc password. This is the only line that had the word Perry written on it. Okay, and remember, etc password holds password information for all the various accounts on your system. All right, so the first field in there is the name of the user, Perry. The next field, X, says that the password is actually being kept in a separate file, and it's encrypted. All right, and that file is the etc shadow file. Then it's my user ID, my group ID, then it's my home directory, and what shell I'm using. Okay, so that's all the stuff that's being displayed there. But like I said, this was the only line in that file that had Perry in it. Okay, so another thing we could do is we could go and grep the etc password file for the word bash. Okay, now there's a bunch more files in here that have the word bash. So there's the root account uses the bash shell. The RPM account uses the bash shell. My Perry account uses the bash shell. And this other dummy account that I created named Bob also uses the bash shell. Okay, so you can see the way that grep works. Now this is the sort of the most simple form of grep. I'm just giving it a string, okay, or word, however you want to think about it. You're giving it the set of characters to look for in a particular file. But grep stands for get regular expression, all right? And a regular expression is a more powerful entity than just, you know, a bunch of characters like bash or Perry, all right? So now let's use grep and actually use some regular expressions and do some searching that way. All right, so we already did a grep on Perry and we did a grep on bash. We could also do a grep on, you know, the number 5, okay? Any character at all is a form of a regular expression. But like we just said, regular expressions are much more powerful than that. They're much more general, okay? So let's take this, this idea here and actually create some regular expressions and learn about what regular expressions are. And then you'll see how powerful grep actually is. All right, here's what I want to grep for. All right, I want to grep for all of the regular user accounts on the system. Now, regular user accounts on the system are 3-digit account numbers, and in Red Hat they start at 500. Okay, so you can see the regular user Perry here has account ID 500. Bob, this dummy account that I created, has 501. The next account that I add would have ID 502, and the next one would have 503, and so on. When I got up to 100 of them, then it would go to 600, 601, 602, and so on. Okay, so let's just assume that we know we have less than 100 accounts on the system. So we're looking for 3-digit numbers that start with the number 5. All right, how can we do that? Well, let's learn some things about regular expressions. One thing about regular expressions is you can specify a dot to represent any character at all. All right, so if I say grep 5 ... /etc/password, okay, then what's going to come out of this? Well, it's going to find everything in here that has a 5 in it followed by 2 characters. Is that going to restrict it the way that we want? No, it's not, right? 5 dot dot will match 5:0. It's going to match 50:. It's going to match 534. It's going to match 51:, and so on. This is not going to restrict it quite the way we want. Let me just show you this. Let me hit enter and watch the difference between 5 dot dot and 5. Okay? It's the exact same list here. The only way that this one, the lower one here, would not have come up with the exact same list is if something in this list up here ended with like 5H or 52 or something like that. If it did not have 2 characters following the 5. All right. If something up here ended in a 5, it would not have matched this lower one. But everything up here that matched a 5 had 2 characters after it. That's why these two things have the exact same output. Okay, so let me clear the screen here. Again, let me do that grep 5 just so we have something to compare to, okay? And now what we want to do, remember, is just look for the things 5 followed by 2 numbers. All right, so now let me show you a new thing here. If I just want to specify numbers instead of any character, the dot specified any character, but if I want to specify just numbers, I can use the square brackets and I can say 5 square brackets, and inside that square brackets I write 0-9. This says any number between 0 and 9, including 0 and 9, has to follow a 5. Okay, what do I want though? I want 5 followed by 2 digits. Okay, so again, what am I going to do? I'm going to put another bracket, 0-9, and another bracket to close that. Okay, so this now is looking for a 5 followed by 2 numbers, okay, in the Etsy password file. Now before you hit enter, think about it. What is this going to match? Is this going to match this first line? Is that going to come up? No, because this 5 is followed by a colon, and a colon will not match that 0-9. All right, what about this next one? 50:. Well, the 5 will match, the 0 will match, but the colon doesn't match the 0-9. Okay, so that one won't come up. What about this NFS nobody account where the user ID is 65534? Well, it will find a match on that line. It'll find like 553 or 534 or something like that. They will match this, okay? And that's not the kind of thing that we want to output. We just want to output the accounts that are 3-digit numbers that start with a 5. Okay, the 51 colon won't match, 5:2 won't match, or 5:n won't match. Okay, but this NFS nobody account will match. Let me hit enter just to show you what gets matched, and then we'll refine this regular expression one more little piece so that it will print out just what we want. Okay, so you can see Perry and Bob come up, but also this NFS nobody account comes up. All right, well, so the last little refinement that we want to do to this expression, let me just write the expression as we had it a second ago, just so that we can use it for comparison purposes. This expression, remember, matched the NFS nobody account because it was 5 followed by 2 digits. So we want this now to restrict this so that exactly 3 digits are matched. Well, how can we do that? Well, one way that we can do that is we can say, since the 3-digit numbers, since there's a colon before and after the 3-digit numbers, we can use that colon in our regular expression that we're searching. So we could say something like grep colon 5 brackets 0-9 brackets 0-9, okay, and follow that by another colon. Okay, I messed up the first bracket there. It should not be a curly brace. It should be a square bracket. Okay, so now let's take that particular expression and let's talk about it. So this is saying match a colon followed by a 5, followed by any digit, followed by any digit, followed by another colon. So this is looking for 3-digit numbers that start with 5, okay, in this Etsy password file. So now if I hit enter, there's the result that we were looking for. The regular user accounts, all those that start with 5 and are 3-digit numbers. Okay, great. So now, say that we wanted to look for all user accounts, and say we had, hundreds of user accounts, like they started with 5 or 6, but still they're 3-digit numbers. How could we alter this regular expression that we just wrote to take care of that? Let me use the up arrow to go back and look at this regular expression, and let's make some alterations to this. So basically what we want to alter here is that we want to change this first number here from a 5 to either a 5 or a 6. So again, we're going to enclose that in square brackets, and instead of just having a 5 in there, we're also going to put a 6 in there. Now this is not looking for the number 56. Okay, just like the stuff in square brackets over here is not looking for the string of characters 0-9. All right, when something is inside of square brackets, it's looking for one thing inside that square brackets. Okay, so it's looking for either a 5 or a 6. The dash in there inside the square brackets represents a range. So this is looking for any one number between 0 and 9. Same for the square brackets here. Any one number between 0 and 9. All right, so now what we're looking for is anything that starts with a 5 or a 6 and is exactly 3 digits long. If I hit enter, we're going to see the exact same thing. But note that if I did have user accounts that started with 600, they would be matched by this, the 3-digit numbers that started with 6, they would be matched by this regular expression. All right, so there is some very simple regular expression tools. We learned about single characters like a colon or a 5, or like a P in Perry, or a B in Bash. We learned about this dash operator that gives us a range, and then these square brackets operators tells us inside the square brackets match one of those things, exactly one of those things, but any one of the things inside the square brackets. All right, well, it's time to wrap up this nugget. We started by talking about environment variables. And remember, we use the env command to look at all the various environment variables and what their settings are for our particular system and our particular session. And then we use the export command to actually change the value of an environment variable. And we use the export command to change the value of the path environment variable, which is probably the most common environment variable to change, especially for new users. Then we talked about the redirection operator. We looked at the greater than sign, and what that greater than sign did is it took the output of the command on the left and stuck that into the file that you specified on the right. Then we talked about the pipe operator, which was a vertical bar, and basically the pipe operator allowed you to use two commands and pipe the output of the command on the left to the input of the command on the right. We talked about the wildcard operator, which is the asterisk or the star. I guess it looks more like that on the screen. And we used that operator to sort of group together files that had somewhat similar names. And finally, we talked about the grep command. And this is a really powerful command in Linux to search through text files. We touched on the surface of what a regular expression is. If you're interested in more about regular expressions, look up on the internet, search for grep regular expressions or something, or look through the man pages or the info pages about grep, and it will go into more detail about the kinds of things that you can do with regular expressions. And we'll see more of those as the video series progresses. Well, I hope you found this nugget informative, and thanks for watching.